This is the video for section 6.2, properties of parallelograms, and what you're going to do is fold this inward. Section 6.2. And we're looking at, for example, that opposite sides are congruent. That means that this side is equal to this side. Also, this side is equal to this side. How will we apply it is that we would set the sides equal to each other. So, for example, 21 is equal to 3.5x. And we would solve for x, divide by 3.5 to both sides. And that would be 6 is equal to x. The next one would be that 5x is equal to 10y. We're gonna solve for y this time, so we gotta use the value of x, substitute it in. So we have 5 times 6 is equal to 10y. 5 times 6 is 30. It's equal to 10y. So then we divide by 10 to both sides. 3 is equal to y. For the next one, we have that consecutive angles are supplementary. Supplementary means that they equal 180. And consecutive means just next to. So for example, this one plus this one would equal 180. They don't have to equal the same measurement, but they are equal to 180. So when we have this, we could do 7x plus 6 is equal to 180. That's 8x plus 6 is equal to 180. Subtract 6 from both sides. 8x is equal to 174. Divide by 8. X is equal to 21.75. Then for the other one we have, it would still be that they equal 180, these two next to each other. We write 10y plus x plus 6 is equal to 180. So I already showed you this one in the front of the foldable. So I'm going to go like this and tell you that these two together also equal 180. And that's the formula we're writing. Once we have that, we're going to substitute in the value of x. Is equal to 180. Combine like terms, 10y is equal to 27.75 is equal to 180. Sorry, not equals, plus. Subtract 27.75 from both sides. 10y is equal to 152.25. Divide both sides by 10. Y is equal to 15.225. So it's common in this section that you will have to find one variable and use it for the other equation. All right, so the next little section is that the diagonals bisect each other. What that means is when you have a diagonal, it will be cut in half, so two equal parts, when you draw the other diagonal. This diagonal does not have to be equal to this one, so I'm going to make different markings that they're different measurements, but it would still cut each other evenly. And then we have that for x squared is equal to 28, because this side would be equal to this part of the diagonal. Gonna divide by 4 to both sides. X squared is equal to 7. How to undo a squared is by the square root of both sides. And then that would be x is equal to plus or minus the square root of 7. The reason that we have plus or minus is because 7 squared equals 49, and so does negative 7 squared. All right, then the next one, so I'm going to make an error that we did that, is 10 is equal to y squared plus 1. We're going to subtract 1 to both sides to have the y squared by itself. 9 is equal to y squared. Then the square root of both sides. 3 is equal to y. So plus or minus 3. Remember, because if you take negative 3 squared, it will still give you 9. Opposite angles are congruent. That means that this angle is equal to this one. I'm only going to use that marking so it's not as confusing. But D and B are also congruent to each other. We just are not going to write it down. But we need to understand that, because when we have a situation like this, we'll know that 6.2y is equal to 124. We're going to divide both sides by 6.2. Which gives you 20. Y is equal to 20. We will also have, so these two were equal to each other, and these two will equal to each other. So I have 7x is equal to 56. Divide by 7 to both sides. X is equal to 8. All right, all are right angles if one of them is a right angle. So if one of them is right, they're all right. So let me just draw the picture. I know that this doesn't look like it's a right angle. All you have to do is be told that it's a right angle, and then the rest of them are. So for example, here's the notation that one of them is a right angle. So 15x is equal to 90. Then this one will also be a right angle. Divided by 15 to both sides. X is equal to 6. 4.5y is also equal to 90. We divide by 4.5 to both sides. Y is equal to 20. And then in the last section, we have the diagonals make two congruent triangles. So these two are equal to each other. And I'm going to erase this because it's hard to understand once both lines are on there. But these two triangles are also equal to each other. So I'm going to call this one 1 and this one 2. So we got this picture over here, and we have this triangle right here. That one's pretty clear that we have a right angle, 8 and 10. I'm going to call this right here A instead of 2x, just to make it a little simpler. But how we solve it is by the Pythagorean theorem. A squared plus b squared is equal to c squared. Since I called this a, then a squared plus, and then the smaller side is going to be the one with the a, because it's always the biggest side or the hypotenuse that's by itself. So 10 squared. A squared is equal to, not equal to, plus 64 is equal to 100. Subtract 64 to both sides. A squared is equal to 36, and then the square root of both sides. A is equal to plus or minus, really, 6. 3, 6. Only that I'm saying that that length is negative doesn't make sense in this problem, so that's why we're just going to leave it as positive 6. Since A was 2 of the x's, we can say therefore x is equal to 3, because that would be half. Okay, so then you have this other little triangle right here. You know that this is 8. So you have a smaller triangle right here. And I'm going to draw it down here just so it can be clear. We have 8, we have x, and we have a y. Well, this time we know the value of x is 3. So then we can do the Pythagorean theorem again, and 8 squared plus 3 squared is going to be y squared. 8 squared is 64, plus 3 squared is 9, that's y squared. That gives me 73 is equal to y squared. So to undo the square root sign, the square sign, you do the square root sign, which we're just going to leave the square root of 73 as the answer to y.